The second piece of automation that I've developed is based on SNMP counters. Now, the original counter that I tried to automate for was based on errors, so then I could very quickly and easily implement the automation to just remove the interface from the lag and use the pre-existing automation that I already created to just show another use case for it. However, I couldn't, for whatever reason, get errors to be triggered. So instead, I focused more on the counters for traffic. So what I did, I identified the counters on the outbound side of the interfaces. And it's a counter in bits, which is a bit of a shame. Now, while I'm talking, obviously, I'm just going to get a ping started. So that ping goes from Juniper R1 to the Juniper Extra right at the top. Hopefully, I've circled them on the diagram for you there. And what I'm also going to get going is an MTR from the automation server to the Juniper Extra as well. Now what that'll do, that'll highlight the interface or the path that we're taking between the two devices that I'm actually automating on. So as you can see here, this is the interface that we're actually hitting on the R2 device. So now we've got that running, what I'm just going to do, I'm going to get the Python interface statistics monitor tool running. Now what this is doing, it's iterating through both SNMP polled interfaces from the device, but it's also running through the interfaces from the database as well. Now, because we previously in the last tool removed all the interfaces from the database to prove the fact that obviously we have that script that will update the interfaces and add interfaces to the database, we have got details of them here, and as part of that we are actually storing counters. Now what you're currently seeing actually on the screen is something that I really did actually want to talk about at some point, which is the config lock between devices. Now because I cancelled out of one of the executions previously, there was previously a config lock in place on one of the devices which hasn't been cleared. Now yet again, that shouldn't have happened, which is always wonderful when these things happen on live demos. But nonetheless, what I'm going to do, I'm going to go back into the database, and what you should see in this case is no config locks, which is very interesting. Let me just refresh that once again, and once again. Nope, there's nothing there. And also what I'm just going to do is go on the interface events. Now this is because we're polling over multiple periods, and obviously polling over multiple periods for the trigger, for the threshold. We want to make sure that, let's say, if we're polling for 5 data points over a minute interval, if we have the original script to monitor the interface utilization polling every minute, we don't want to trigger off, let's say, 5 executions to poll for the utilization of the interface for, yet again, 5 more intervals. We just want the first execution which saw the break of the threshold to be counting that. So this is what I'm doing here. This is what this table is for, and it will monitor the state of interface events, and it will have the event ID, so then it can actually identify with that and then the interface ID whether there is an issue, and if it isn't resolved, then it will ignore that issue entirely. Now going back to the script here, I am just going to clear that, and I'm going to run that again. And what you can see is it iterates through a few devices, and then it will iterate through all of the interface from high to low. Now obviously in a perfect world, this would be threaded, and we would trigger on the interfaces, we would poll for the first point on the interfaces simultaneously. However, in this case, I'm just doing it one by one, so we can see that when we are doing the automation, that as you can see there, we've applied the metric, and then it's gone ahead and changed the route. Now, for some reason, after it does that, it fails, and I'm not exactly sure why. I'll go ahead and double check that, and probably put some colourful Comic Sans on the screen, just to just to confirm what the hell's going on there. It looks like I'm checking for state on the result of something, and it's not liking it exactly. Now, I've not seen that before, and I've done plenty of testing on this, so obviously I've missed out a use case or an edge case, so I'll go back and obviously just make sure that's fixed. But going back over it, so as you saw there, that was the original path with inside the MTR, and then that was now the second path that it's taken. And we can see that the traffic has changed, because originally it was taking the G0015 interface, and that's why it had that high utilization. So what we see with inside this script is that it'll have a previous counter, it'll have a current counter, so the counter from the current the poll, and then it'll have the difference in the amount of bits, the amount of the current time, the previous time, the amount of seconds since, the bits per second, so that's basically taking that number, dividing it by 5 to get an average. It then identifies the speed of the interface, and from that it can then identify the utilization, basically dividing it by each other, to identify, in this case at that point it was 15% utilized. At this point it will then keep on polling through, and as defined by the script, it will know the threshold, so in this case it's 10%. It'll have an interval, so that is in seconds, so 5 seconds. And then minutes, I should probably change that variable to be something more appropriate. But basically what that does is it checks 5 times. So that's the amount of polls, that's the amount of data points, I should probably call that. So yes, that's that tool. And as part of that tool, what we have actually in the background is a tool called the deprefer tool, which will actually change the interface cost based on OSPF. Now, obviously, in this case, I'm triggering a very rudimentary addition of cost onto an interface. However, in a real life scenario, you could trigger, let's say, some more advanced traffic engineering system, or you could actually implement, let's say, a similar thing as to what I've done, or you could actually implement just, let's say, cutting a ticket to an engineer or sending an email to someone. So that's everything for that one single tool. And then there is one final tool, which is the automatic addition of BGP peers.